discussion. Okay. Okay, sorry, I don't mention you. So you don't notice that. Okay, so let's pray together to start our lesson. Allahumma inna nas'aluka ilman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Rabbana zidna ilman warzuqna fahma. Rabbi ishrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Amin. Okay, before we continue discussing about the problem in the contest, so have you read about pointer? Did you understand about pointer and and anything related to that material? Okay, tapi I will show you about the simple example related to the pointer. All right, let me share my screen. I think the server is still error. Okay, so let me explain about the pointer. For example, we define a variable, an integer, and we assign a value here. Then we can also define a pointer like this. If integer mean a variable with this data type, but the syntax means a pointer that pointing an integer. So let's make it p. So p is not a variable, but memory address. Okay, so p is a memory address, which is initially 0. It means doesn't pointing anything. And then we can make it pointing variable a with the syntax. So ampersand a means the address of a. This means the address of a. So p doesn't storing an integer but storing an address. Okay, so we can store an address here. So if we want to output the value, don't do this. If we see out p directly, then we just outputting the address. Okay. So can you try to open code interview? Is the server is error or just in mine? let's just output memory address. Okay, maybe I will create another code interview link because the previous link is still error. Okay, and then for example, like this, we create a variable a which is equal to 10, for example, and then we create a pointer b, and we can also code this or this. This is equal to the address of a. Okay, so if we see out a, then we will outputting the value of a. But if we see out b, we will outputting the value of b, which is an address. Okay, then we will see like this memory address. All right. After that, how to outputting the value of b, then we can do like this. This means we are not outputting b, but outputting a value that pointed by b. Okay, like this. And then what if we change the value? For example, this is the variable pointed by b, and we will change the value like this. Then if we see out a, then the value will be changed. Okay, become 15 because after is b means variable a, right? All right. After that, if we create another variable c, for example, the value is 20, and then we want to change b into the address of c, then now b pointed into another address, right? Which is the address of variable c, and finally we can output the value of c. And of course, now if we change the variable a, then p is not affected, right? P is not affected because p already pointing variable c. Okay, for example, a plus plus, and then do this, then c will be, then p equal to the address of c, which is c equal to 20. All right. Now, is there any question? Okay, then what if we create another pointer g, which is equal to p? Then if we outputting g, it will be also equal to c, right? And then after that, if we change variable p, okay, of course the value of p is changed, But how about t? The value of t is doesn't change. So we can imagine like this. A and C is storing a value, right? But D and D storing address. So for example, here address of A. So we can change it or outputting it. And then if we change the address, the value, so this address is changed. Okay. But if we do this, the value of B is doesn't change, but value A did. Okay. Value A changed. Okay. And then if we create another pointer and the value is equal to B, so because B is equal to address of C, then D also equal to address of C. Okay. So if we output D, then this is pointing variable C and then C out 20. But if we change the value of B, then D doesn't change. So we still can outputting D like this. All right. So how about the last material that we, all right, what is the benefit of pointers? We can, at first, we can pointing variable like this. For example, we can, sorry, or for example, we have a vector. For example, the size is n, and n is large. For example, 100,000. So if we want to push into a parameter, for example, we have a function which the parameter is vector. Okay, if we do this, then the complexity of pushing function here will be equal to the size of the function because we copying the value. Okay, so if we do this, for example, if n equal to 0, then return x0, else return xn plus fxn minus 1. For example, there is a recursive function like this. Do you know what does it means? That's it, the sum of an array. Okay, then what is the complexity of this function? Okay, we will call the function on times, but in one calling function, actually we will copy the factor one by one. For example, we have a factor with size 100,000, even if here only 1,000, but we want to copy all the value here, and then after that we call another function. We will copy again here. Okay, memory limit exceed. Yeah, if the memory limit is small, then it will be memory limit exceeded, because we will copy to the other x one by one all of the value in the vector, and then we will call another f and copying the vector again, and so on. Yes, take memory as well. So the complexity is n times the size of vector. Correct. And maybe let me give you the small size first, and let's see what is the result. Do you know what will be in the result if we implement like this? That's right, thank you. This is solve P9 because this is 0 indexed. Okay, and then what will be the result? What is the result? 45, really? We put I plus 1 here. Okay, 55, I think. Let's try to run it. Sorry, this is solve it's okay, 55. That's right. And then what if we do this? For example, okay, for example, like this. And then we want to outputting the vector. What is the output in the second line? Do you know what is the output of the second line? That's right. 1 to 10, same as assigned. Let's try. Okay, correct. And then how to speed up and to save the memory in this function, we can change it into a pointer. So we can just push the address. Okay. So we have to make it like this. All right. So what will be the answer? Okay. Sorry. Maybe is it correct? Yes, you can. We can also make it ampersand. Actually, it is a different concept, but okay, this is also correct. All right. Then the value of the factor will be sales, right? So, and then what is the complexity? The complexity will be just ON. Okay. So this is faster. If we don't put ampersand here, then the complexity will be n times the size of the factor. Okay. Which is n squared. Okay. But if we use the concept of pointer here, so here we don't copy to another memory, but we just storing the address. Okay, so we just storing the address, so we can change the value in that address, and we also can use or read the value of the address. Okay, and here also just copying the address. So copying the address will be only O1, and copying all the value will be ON. So this is faster. Okay. Is there any question about it? Okay. And then what is a row function? Do you know about a row function? Okay. A row function is like this. For example, we have a pointer here, and this is equal to the address of P. So we can push back like this, right? We can push back like this, and then we can output the size, right? Yes, maybe we have to put bracket here. Inline function, not really. Okay, we can push back like this, right? And then this value, the size is 11, right? So maybe we have to make a new line here. Okay, the size is 11 because we already push back here. Okay, so this is quite disturbing because we have to put bracket and then put asterisk here and then put dot here, and we can make it simpler with just do this. Right, we can change it into a row. Okay, this is same. All right, so the conclusion is dot function is for a real variable, for example dot first, dot second. But for pointer, for example x is not the variable but the pointer pointing some memory address. So if we want to do dot function not in x but in a variable that is pointed by x, so we can just make it a row function like this. Okay, so a row function means we will do this function, this dot function, in a variable pointed by this, not directly x because x only storing an address, right? Okay, that's the different. So this is equal to this. All right. Is there any question? No. Okay, then if we want to create dynamic segmentary, actually we can also do indexing manually, but we can also using pointer like this. For example, we have struct of segmentary, then it has some value and lazy and the segment index, and then the left child and the right child, and make it a pointer like this. Right, we have to put semicolon here. But if we don't put pointer here, then this will be infinite recursion, right? Why? Because Segtree will has another two Segtrees. Okay, and then each of them also has another Segtrees again, and so on. Then it will be infinite recursion. Okay, and we cannot compile this. But if we make it a pointer, then this is not a problem, since the pointer can pointing nowhere. So this is just 0 or null variable, and this is null. Okay, and then if we create another segmentary, then it will pointing null, and so on. If we create another segmentary in the left, we will null here, and then null, and so on. So this is not infinite recursion, but will be finished until we got null address. Okay, so this is how to implement a dynamic segment tree. All right. Until this point, is there any question? After that, let's discuss another problems about segment tree. Have you read this problem? Okay. Okay. Then in this problem, there are some ends, and each of them has a string. And then for each, then you will choose L and R, and some of them will 5. Right. So here in this example, an ends will hit another end when the strength is multiply of the second one. Okay. For example, 3 and 1, and then 4, 2, 4, 2, and 2, 2, and of course, each of them repeat 1. Okay, sorry. Okay, and then going to fit only if he beat all of them, right? If he fit all of them, then will be free. So the number of free ants is only sorry, the number of free ant means all of the ends that is still of the other ends. For example, like this. Here from 1 to 5. Is it true? Okay, yes, because this fit all of them, so this will be freed. So the mole only eats 4. And how about this? No one to feed all of them, all of the other ants. So the answer will be 4. And how about this? 2 to feed everyone, 2 to feed everyone. So we will, so the mole only eats 1. And then for 5 also. So now we can know that the the number of freed ends, sorry, all of the freed ends is must be the ends has the minimum strength, right? So in the minimum, and all of them must be the multiply of it. So the greatest common divisor should be equal to this. Okay. So we can make a segment tree that is storing 3 variables: the minimum, the greatest common divisor, and also the number of minimum. Okay. What does it means, the number of minimum? So we can make it like this. For example, we have a struct of value, or struct of segment. So sometimes we need to store, for example, like this. We need to store 3 variables, which is minimum, greatest common divisor, and also the frequency of the minimum. And here there is no update, right? So we don't need lazy. And then we also can do this, or I prefer to read a different struct here, segment, which is equal to value. And in order to join them, we can also create an operator. Okay. Have you implement like this before? Minimum equal to minimum between minimum and x minimum. Okay, and then the greatest common divisor equal to greatest common divisor between this. After that, How about the frequency of minimum? The frequency of minimum means like this, or yes, we can do like this. If the result equal to the minimum like this, then we add the frequency by frequency like this. Okay, then return that. So it means we define an operator. So when we do this, for example, we want to build like this. If x equal to y, then file MP we also have to create another build function here. Build means create the initial value. Okay. After that, after creating the left and right, and finally the value just equal to left value plus right value. Okay. Or maybe let me complete the implementation first. New Segtree, then left build x mid, then right from mid plus one until y. All right. What does it means? New Segtree, because initially left is pointed null variable, which is doesn't point at anything, doesn't point anything. So we will create a new segment tree here, right? New node here. Okay. And also the right pointing the new node. And then we want to build the value here. Okay. To recursion here, which is covering x until mid and here mid plus one until y. After we get the value of each of them, then we will combine them into one node, right? How to combine them? Here we already define the plus operator like this, right? So it means we already combine it. We already find the minimum of the combination and also the greatest common divisor and also the frequency. Did you understand this? Maybe the other way to put this is like this. Okay, this is another way to combine it. So we can create an operator here. So this is the just like a function with two parameter. For example, a plus b, and then because we define it in struct sec, so the data type for a should be sec. So if a segmentary or data type sec here plus by another variable which is also sec, so the result will be also sec. Okay, for example, if we add integer with integer, then the result will be integer. Okay, and for example, long long plus integer, the answer will be long long. Okay, here this segment plus another segment, the result will be also segment. Okay, so we want to return a variable rate here, so we have to find the value of red.gc, red.mn, or red.fr. And then what is the GCD? Of course, the GCD between this variable. This variable means we don't need to, or we can do like this also, this.gc. Okay, that we can directly make it like this. The greatest common divisor between this variable and the greatest common divisor of the other segment. Okay, and also how about the minimum? We will compare first between this minimum and the minimum of x. If this is smaller, then we can make it mn, but if x is smaller, then we can make it x.mn like this. If it is same, so equal to one of them, up to you, and then the frequency will be added between the frequency in the left segment and the right segment. Okay. Alright, this is how to implement this problem if we want to use a struct and a pointer. Alright, is there any question until this point? Is there another class after this? So we have to end now, or we can extend our class. So if there is no class after this, there is no class after this, right? Okay, so we can continue maybe a few minutes. Okay, and this is not always plus. We can also, for example, I will make it like this. So the operation will be like this. Or for example, I will make it like this. It is also can be do it. Or maybe, for example, asterisk here, or just plus or minus. Okay, we can define our own operation. All right, then in the main function, if you want to query from L to R, then we can do this. For example, we can create a temporary segment which is equal to root dot query from L to R. Then what is the result? We will check first whether the minimum is equal to the greatest common divisor. If it is equal, then the result is R minus L plus 1 minus the number of minimum or the frequency of minimum, like this. But if the minimum is not equal to the greatest common divisor, so all of them is correct. Okay. Like this. All right, you got it. Okay, great. Then we can continue to the next problem. Right. There is a query and update problem. Is initially we have two array A and B, and then the second type of query means we have to output the value of B with specific index. So the value is 0. After that, when an update occurs, this means we want to change like this, starting from 3, and the length is 3. So we want to add to this. So this will be equal to -3, and this is 3. So when we outputting the the fifth index, the result is 3. Well, the fourth index, sorry, this is copying, right? Okay, sorry, it's copying, so the value will be -1. All right, and this is still 3. After that, if we want to do this, then we will copy from this from the second index with the size 4 into this. So this will be equal to 2, this is 0, -1, and 3. Okay, all right. So because we want to update a range, not point update, but range update. So we will we need lazy segmentary, right? Then what we shall store in the lazy variable here. So we just need to store what is the index of A of the copied variable. So when we do update, it will be like this. For example, this is the value is this value, and then we have lazy also. And then when we want to create an update function, we will do like this. We will update from X to Y. And then maybe X, Y, and K, right? Or we can change it to X, Y, Z like this, which means we want to update from X to Y, and index A will be assigned from index Y. So when we input the update parameter like this, then we want to do update from Y until Y plus K minus 1 become X like this. Okay. Then usually if we want to update, there is some base case like this. And then if X might less than or equal to L and Y are less than or equal to Y, then we just want to change the value of lazy. The lazy is equal to L minus X or Z plus L minus X like this. Then just return it. Maybe let's change the value become the first value, which is equal to the array of lazy, for example. All right. And then if we want to, yeah, we don't need middle, right? We just want to push, and then we just want to update to the left and the right. Why we use an arrow operation here? Because left and right are pointers, right? Just like this, left and right is pointer. This is pointer, so if we want to access the value, we need an arrow. And then how to push the value. Say if lazy equal to 0, we do nothing. But if lazy is not 0, then the left value is equal to the index of lazy like this, and left lazy will be equal to the lazy also. How about right value, or maybe we will start from right lazy. Right lazy equal to lazy plus what? Plus right L minus L. Okay, then we will do this. Okay, do you know why? Because for example, we want to make it starting from 4 here. So we want to copy from 4, 5, 6, 7, 8, 9, 10, and so on. And then if we want to push to the children, the left child will do lazy 4, and the right child will do 8. Why? Because we starting from this. Or pushing lazy. Yes, push means we want to push the lazy propagation from the car node to the left and right node. So because if we directly push it each time we update, then the complexity is ON, right? So we only stop until this and storing the lazy value here. But every time we want to visit the child, we have to find this, or we have to propagate the correct value. Of course, this is different because let me define what is the lazy. The lazy means we want to assign all of the segment become lazy in the leftmost, and then lazy plus 1, and then lazy plus 2, and then lazy plus 4, and so on. So in the left side, the lazy is just the same, but in the right side, the leftmost index will be stored lazy plus 2. Okay. Maybe there is another solution, another implementation detail. This is just one of the solution. All right. This is the solution of the problem D. All right. Until this point, is there any question? And I'm sorry, I only can attend the class until now. So let's continue the to Friday, the next Friday, the day after tomorrow, and we will discussing about the next problem. And if you have a question or a problem that you want to ask, a problem that you want to discuss, you can ask it to me. All right. Maybe that's all for today. And thank you for waiting me to start the class. And see you later in the Friday. And let's close our meeting with praying. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.